alpha particle scattering formula. You're going to consider an alpha particle here. The alpha particle has a charge, which I'm going to call Q1 of positive 2e. And I'm going to have a nucleus here. The gold nucleus has a charge. I'm going to call it Q2, Ze. And the particle now is moving towards the nucleus. Moving towards the nucleus. Let me have and as it's moving towards the nucleus, its kinetic energy is increasing. At a certain point of closest approach, is the particle moving. We are going to have the particle starting with a kinetic energy, and then we are going to have this particle possessing also electrostatic potential energy here. Now, as it is moving towards the gold nucleus, what do you expect? Then we are going to have this one as this distance as r. R is going to be distance of closest approach. So as kinetic energy is decreasing here, we expect the potential energy to be increasing. The kinetic energy of the particle is decreasing, which is at this point, and then the particle will momentarily stop. At that stopping point, we are going to have the kinetic energy being equal to the electrostatic potential energy. But then for this case, our kinetic energy is equal to 1/2 mv squared, where v is the speed of the alpha particle before collision. And we are also going to have the electrostatic potential energy, which is Q1, Q2 out of 4 pi epsilon r, whereby our Q1 here is 2e, and then our Q2 is Ze out of 4 pi epsilon r. This is going to give us 2 Ze out of 4 pi epsilon r. Now at a point closest to the nucleus, we are going to have the kinetic energy being equal to electrostatic potential energy, which is 1/2 mv squared, being equal to 2Ze squared out of 4 pi epsilon r. Our aim now is to make r the subject. Simple math. Make r the subject, and you have r is equal to Ze squared out of pi epsilon naught mv squared as the distance of closest approach. So that's what we are having. You're going to use this formula, derived formula, to solve different calculations, where you're given a certain beam of an alpha particle incident on a thin gold foil, and you're asked to determine or calculate the closest distance of approach of that alpha particle. You'll be given the atomic number, and yeah. So that is it. Our next will be the Bohr's